Good afternoon, everyone. My name is Yidan Zhang. Today, I will present our study entitled From Technology to Value, Aligning Digital Twin Maturity with Business Model for Infrastructure Management. This study is an initial exploration trying to find any insights from the current literature to explain how to connect digital twin maturity with suitable business models, and thus to improve the transition from technology development to value generation. The presentation is structured into 6 parts. First of all is an introductive section where I will introduce the research problem and the research aim. Well, in principle, digital twin connects the physical assets and digital representation through continuous data acquisition, analytics, decision support, and potential control. While digital twin is an invaluable tool, in practice, many of its applications remain at the pilot and the prototype stage, far behind the scalable deployment and becoming value-generating services. Therefore, the starting point of this study is simple. Why this happen and how to address this? In response, many studies have sought to address the technical barriers to fully realize digital twin potential, such as the problem of data quality, standardization, and workflow integration. However, far less attention has been given to business-related barriers, particularly the difficulty to prove financial value and the lack of appropriate business model. What we should consider is no longer how to develop a viable digital solution, but also how can this digital twin create, delivery, and capture the value. Also, even some studies discuss the digital twin maturity models and the business models. They are usually discussed as 2 separate topics and with limited attempts in the field of infrastructure management or the broader built environment. Therefore, the aim is to align typical business models associated with infrastructure digital twin at different maturity levels to improve the technology to value transition. These slides introduce 2 foundations of the study. A maturity model of digital twin is a structured framework that defines an evolutionary path from an initial to a final optimized state. It normally includes maturity level, concise label, and a generic description of each level, and a maturity domain, and the measurable indicators. As for the business model, it expands the logic of value creation, delivery, and capture. It usually answers 4 questions. Who is the target customer? What is offered to them? How is the value proposition created, and why is it profit? This knowledge provides a basis for the review by highlighting the areas that require particular attention. This study adopted a systematic literature review. Relevant publications were identified from Web of Science using keywords related to digital twins, business models, maturity models, and infrastructure. The search focused primarily on English language studies in civil engineering, industrial engineering, and multidisciplinary engineering. After duplicates were removed, the remaining publications were screened based on their title, abstract, full text, including the 12 additional records from snowballing research. The whole process resulted in 56 publications being selected for detailed analysis. The review was guided by 5 research questions. Regarding the conceptual and the theoretical research, we focused on how to define the maturity levels of digital twins and what kind of a business model are suitable for digital twins. And for the practical research, we aimed at what is the maturity level of the digital twin application, and what are the core business model elements of the digital twin application. Then to synthesize, we attempt to answer which business model are viable at each maturity level of digital twin for infrastructure. Based on the review, this research proposed a maturity spectrum for digital twins. This figure presents the selected conceptual study from infrastructure and closely related domains, and it shows how this study defines the maturity levels and the future capability at each level. The different shades of blue indicate that in the study, the corresponding maturity level has been defined. It was found that most studies define 3 to 5 maturity levels, with only interactive digital twins consistently being included, showing great disparity in the understanding of digital twin maturity. Also, it was believed that the first 3 levels are not true digital twin, as they lack the core capability of bidirectional interaction and simulation. Overall, high maturity digital twin involved through AI-enabled analytics, closed-loop automation, and integration from isolated assets to wide infrastructure ecosystems. Table 1 further defines the key characteristics of a digital twin of each maturity level, and generally, the various levels of digital twin can be differentiated by data management, analytic and intelligence, automation and control, as well as integration. Then, by reviewing the practical research, this table links the digital twin of a different maturity level to 4 core components of business model: customer segments, value proposition, value proposition, key activity, and revenue streams. It was found that in the infrastructure application, digital twin has been used across both standard-alone assets, such as airport, and integrated systems, such as highways, with most applications remain at the interaction digital twin levels. And value proposition refers to what the digital twin offers. At the lower levels, some value proposition is mainly providing the data, information, and knowledge to support the decision making. And at the higher level, it moves towards optimization and lifecycle management. Accordingly, key activities mainly include data management and analytics to achieve the value proposition. Only the high-level digital twin has the capability to conduct prescriptive analytics, in addition to descriptive, diagnostic, and predictive analytics. Revenue stream include project-based payments suitable for digital twin with low maturity, while performance-based payments, usage-based payment, and subscription for these with high levels. To conclude, it synthesizes existing digital twin maturity classification and proposes a more comprehensive spectrum. And second, it shows that many digital twin applications in infrastructure are still at an early stage, and the term digital twin is sometimes used too loosely. Third, digital twins are widely used in infrastructure but remain at the interactive digital twins. Fourth, it aligns digital twin maturity models with maturity levels with business model components, showing how value proposition, key activities, customer segments, and revenue streams change as the digital twin become more mature. Future research should validate the proposed alignment in specific infrastructure tests because business model may differ across the different type of infrastructure. Thank you.
Any questions? Yes.